dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's discussion will be about isometric projections of the combination solid in which a pentagonal pyramid, it is lying centrally on top of a cylinder, right? So there are two solids which will be involved in this construction. At the bottom we are going to draw the cylinder, and on the top of the cylinder a pentagonal pyramid will be resting over it. Now let us go through the statement. We are required to draw the isometric projections of the vertical regular pentagonal pyramid which is resting centrally and it is having one of its base edges away from the observer. So this thing is very important. One of the base edge of this particular pentagonal pyramid, it is lying away from the observer and parallel to the vertical plane. So we will see how we can go about locating this edge away from the observer and parallel to the vertical plane. And this pyramid is resting on top of a vertical cylinder, and here the edge of the pentagon, it is given to us as 32 millimeters. So this is the edge of the pentagon, and the height of this pyramid, it happens to be 50 millimeter. Now when we are talking about this edge, that is edge 1, 2. So this edge should be located in such a way that this edge should be drawn away from the observer. That is, this corner 4 will be facing the observer and this edge 1, 2 will be drawn farthest away from the observer. And another condition is that this edge 1, 2 should be drawn parallel to the vertical plane. So while we are constructing this pentagonal pyramid, so we will see how we can locate this edge of the rectangle AB away from the observer and this edge of the rectangle CD. This will be drawn closer to the observer, right? Next, we have got a cylinder which is having the diameter equal to 65 millimeter and the height of the cylinder is given to us as 40 millimeter. So this is the diameter of the cylinder, so which we have marked as 65 millimeter. So this is 565. So we cannot draw this cylinder directly onto the isometric projection, right? So this circle will appear as an ellipse in the isometric projection. So in order to draw this ellipse construction in the isometric projections, so we need to inscribe this circle into a square, and the edge of the square will be equal to 65 millimeter. And since the cylinder is resting upright onto its base in the horizontal plane, so this square will be drawn on the base that is in the XZ plane over there, and the height of the cylinder will be marked as 40 millimeter. Similarly, regarding this pentagon, so we are not able to draw this pentagonal construction in the isometric projections. Reason? Because the angles and the shape of the pentagon will not be preserved in the isometric projection. So what we have to do in the case of pentagonal construction, we have to draw this geometric figure of the pentagon having an h is equal to 32 millimeter, and once we draw this edge length equal to 32 millimeter, so the construction of the pentagon will be completed using the standard procedure. That is, all the external angles we are going to draw equal to 72 degree. So once you extend this, again the 72 degree external angle will be there. Now once we complete this construction of the pentagon having the edge 32 millimeter, next we have to inscribe this pentagon into a rectangle, and once we are able to obtain this rectangle, we will find out that there is a longer edge AB of this rectangle and there is a shorter edge BC of this rectangle, and this longer edge will be given the name dimension X. Similarly, this shorter edge of this rectangle will be named as edge Y over here. So once we draw edges X and Y onto the isometric projections, then the points of the hexagon, that is the 1, 2, 3, 4 and 5 points. So these points corresponding to the edges of the hexagon, they can be located appropriately in the isometric projections using the rectilinear distances, right? So with this background, now we are going to start with the construction of, first of all, the cylinder, and then we will see how we can locate and place this pentagonal pyramid centrally on top of the cylinder. So in order to draw these dimensions, so first of all, the true lengths of all of these dimensions, they will be evaluated, and then using the isometric scale, so these true length dimensions, they will be converted into the isometric dimensions, and only these isometric dimensions, they will be plotted onto the isometric projection. Now this is the starting point of the isometric projection, that is, you draw a ground line or a datum line. This is called horizontal datum line. Then we are going to mark a point over there, and the x-axis will be drawn at an angle of 30 degree towards left hand side, and the z-axis will be drawn at an angle of 30 degree towards the right hand side. Now this is the x-axis, this is the z-axis, and since this is the cylinder that we need to draw first of all, and this cylinder is resting upon its base, which is circle over here, into the horizontal plane. So now we are required to draw this square base onto the x and z planes over there, right? So on the x-axis, I have to mark this edge is equal to 65 mm for this square. Similarly, along the z-axis, I will be marking a distance of 65 millimeter, which will be the second edge of the square. And regarding the height, so the height of the cylinder will be marked along the y-axis over here. And how much is the height of the cylinder? The height of the cylinder is given to us as 40 millimeter. So let us complete the base of the cylinder. Now we have the square corresponding to the base of the cylinder, which we have completed over here. So this is the dimension length equal to 65 millimeter along the x-axis. Now along the z-axis also we have marked a distance of 65 millimeter. Then two isometric lines, they have been drawn parallel to x-axis and the z-axis. So this edge has been drawn parallel to the x-axis, and the length of this edge will be equal to 65 millimeter. Similarly, this is again an isometric line which is corresponding to one of the edges of the square, and this has been drawn parallel to the z-axis, and the length of this edge, it happens to be 65 millimeter. So with this, the construction of the square which is going to house the ellipse, which will be drawn corresponding to the circular portion of the base, this has been completed. Now we have to complete the top face of the cylinder. So in order to complete the top face, we have to draw the vertical axis, that is equal to 40 millimeter. This is the height of the cylinder. So all these vertical edges, they will be drawn parallel to the y-axis, right? So this is the y-axis, and the 40 millimeter edge length has been drawn over here corresponding to the height of this particular cylinder. Now corresponding to the third point, and we have completed the bottom over here. Now let's complete the top face. So in order to complete the top face, once again, this is fourth vertical edge. Now two horizontal edges, they will be drawn parallel to the x-axis. Similarly, two isometric lines, they will be drawn parallel to the z-axis. So this will complete the construction of the top face. So please check, this is the construction of the top face, and this is the construction of the bottom face of this particular cylinder, right? So since this cylinder has been inscribed in a square, so we are getting a square prism over here, right? So in the bottom you have a square, in the top again you have a square, and this is the vertical height. So this is a square prism. Now we need to complete the construction of the circular portion at the top, which will appear like an ellipse. Similarly, we have to complete the construction of the circular portion corresponding to the bottom face or the base of the cylinder. Again, this will be an ellipse. Now we have drawn two squares over there. Please check. We have drawn two squares which are going to inscribe these elliptical construction. And square, when you draw in the isometric projections, they will be appearing like the rhombus over there. So the top face also appears like a rhombus, and the bottom face also appears like a rhombus. So let us start with the top face. So in the top face, once we join the diagonals of the rhombus, you see here we have joined the two diagonals of the rhombus, and we know that the diagonals of the rhombus, they are not equal. So there is one major diagonal and there is one shorter diagonal which we call as minor diagonal. Now our focus of attention is this one, that is the minor diagonal. So to begin with, what we are going to do, we are going to obtain the midpoint of all the four edges of the top face of this particular square construction. So this is a square construction. So for all the edges, we have evaluated the midpoints of all the four edges over there. Then corresponding to this minor diagonal of the upper square, what we are going to do, from one corner I will be drawing two projector lines which will be joining the midpoint of the opposite edges of the square. So this is again the midpoint of the second edge which is opposite to this corner, and this is midpoint of the first edge which has been joined by using projector 1 and projector 2. Similarly, corresponding to the second end of this minor diagonal, again two projectors will be drawn which will be joining the midpoint of the opposite two edges. So this is edge number 1. So this is my projector number 1. This is my second edge which is opposite to this corner of this minor diagonal of this rhombus. Now this is my second projector. Now once we have made these constructions, next all the four centers will be located which will facilitate the construction of the geometric figure of the ellipse over there. And the name of this method is called four center method. So this is my center number 1, this is my center number 2, this is my center number 3, this is my center number 4. So from center point number 1, I am going to take this much radius, or I will be taking up this much radius. So with C1 as the center, radius is equal to this much or this much radius. I am going to draw an arc using a compass which is going to join this midpoint with this midpoint in a circular way, because this is the radius center point over here. Similarly, now with C2 as the center, I will be opening my compass is equal to this radius or equal to this radius. Both these radii, they will be equal. So with C2 as center, radius is equal to this much. I am going to draw the second arc over here, right? Then using the third radius point, center point, C3. So using C3 as the center point, radius is equal to this distance or radius is equal to this distance. So my third arc will be completed with C3 as center and radius is equal to this distance. Finally, this is my center 4, and from center 4, I will be opening compass is equal to this much or equal to this much. So with this as radius, center point as C4, the fourth arc will be drawn. So this completes the construction of the circular portion which is appearing like an ellipse on the top face. Now, same construction has to be followed corresponding to the base of the cylinder. So corresponding to the base, we have already drawn a square portion. Please see, a square surface has been developed, and Now once again, corresponding to this square which appears like a rhombus, I am going to join two diagonals, major diagonal and minor diagonal, and once again midpoints of four edges of the square they will be obtained. Now once again our point of attention is this minor diagonal. So from the first corner of the minor diagonal, two projectors they have been drawn which will be meeting the midpoint of the opposite edges. So this is first edge, so this is my first, you see, projector, this is my second opposite edge corresponding to this corner. So the midpoint of this edge has been joined by a projector. Similarly, from the second corner of this minor diagonal, again a projector has been drawn which is going to join the midpoint of the opposite edge on one side. Similarly, on the other side, this is my second edge and this is the midpoint. So I am going to join this corner with the midpoint of this opposite edge as well. So having made this construction, now once again as per the four center method, so the four centers they have been located: center 1, center 2, center 3 and center 4. So similarly, with C1 as the center point and radius is equal to this much, first arc has been drawn. Similarly, with C2 as the center, radius is equal to this much, second arc has been drawn. Similarly, from center 3, radius is equal to this much, so the third arc has been drawn. And finally, with C4 as the center, radius is equal to this one or this one, again fourth arc has been drawn. So the construction of the cylindrical portion of the base and the cylindrical portion of the top, that has been completed. Now let us complete this construction of the cylinder. Now the two vertical edges they will be visible to the observer. So these edges they have been darkened, right? So these are the boundaries corresponding to the height of the cylinder. Similarly, corresponding to the base, so the front portion of the semicircular portion of the cylinder will be visible to the observer. So this will be darkened now. So please check, this has also been darkened. So in the usual circumstances, had there been no other solid resting on top of this total surface of the cylinder would have been visible over here. So we would have darkened this entire portion. But for now, we know that there is a pentagonal pyramid which is going to rest centrally on top of this particular cylinder. So I cannot darken this total portion, that is the circular portion of the cylinder. So what I will be doing, first of all, I will be making the placement of this pentagonal pyramid on the top of this cylinder, and then whatever portion of this top face of the cylindrical portion is going to be covered by that particular pentagonal pyramid, so that will be left as it is, that is drawn in the lighter mode, whereas the rest of the portion it will be darkened out. So let us now draw on the top of this particular cylinder the pentagonal pyramid. Now one thing we need to remember, that there is one edge of the base which is away from the observer. This is first thing we have to observe. Second, this edge should be parallel to VP. So please check, I am talking about this edge. So this edge happens to be 1 to 2. So this edge will be located along this direction, because you see, observer is going to look at this particular solid combination from this side. So since observer is looking from this side, so this edge 1, 2, if I place it over here, both the conditions they will be satisfied. This edge will be away from the observer and this edge will happen to be parallel to the vertical plane, right? So this is the corner which will be facing the observer. But before we start working upon this construction, now first of all I have to locate this rectangle on the top face of this particular construction over here, and this center of this particular pyramid, so this should be resting with the, it should be matching with this center of this particular cylindrical portion. So for that purpose I need to work out the axis over here. So please see, the center points have to be located. So this is my top face side. So So I am going to obtain the midpoint of this edge. Similarly, the midpoint of this edge will also be obtained, and then these two midpoints once I join, so I will be getting a center line which will be parallel to my z axis. Similarly, the midpoint of this edge corresponding to the square will be evaluated. Similarly, the midpoint of this edge corresponding to the top face of the square will be evaluated, and this midpoint they will be joined. So one center line will be obtained which will be parallel to the x-axis. Now next thing is, this is the construction of a rectangle, because we have already discussed that this pentagonal shape cannot be directly translated or drawn onto the isometric projection because of the presence of these non-isometric lines. And in the isometric projection, neither the angles nor the shape will be preserved. So that is why we have drawn the geometric construction of this pentagonal shape with an edge length of 32 millimeter, and then inscribe this pentagonal shape within a rectangle. Now this rectangle will be drawn over here first of all, and as we have to draw this rectangle, on the top of this we know that there are two dimensions of this rectangle. One is the dimension x. X means A to B distance, that is the longer edge. Other dimension is y. Y dimension corresponds to the side BC, which is the shorter dimension. So what I have to do now, I have to locate this centrally on top of the particular square. This is my square, so this rectangle has to be located centrally. So please check. Now with respect to this axis point, now I have to locate this rectangle onto this particular square surface such that the center point, that is the axis point of the cylinder, should be matching with the axis point of this particular pentagonal shape. So what I have to do, please check. I know the dimension x, I know the dimension y. Now I have to place this rectangle x and y onto the top along this edge. I should be able to place my dimension y. Similarly, along this dimension I should be able to place my dimension x. Now how I would be placing over there? The center point, that is the axis of this point, should be matching with the axis of the cylinder over there. So I have drawn these two lines. You see, these are two lines, projection lines, which I have drawn. And how I have been able to manage to draw these lines, construction lines, please check this out. This is my distance x between these two projector lines. But then how I have drawn this, please check. This is my total distance x, and this is my center line over here. So this center line means that onto the x orientation, so this distance of point 1 to this center axis line, so this is the midpoint, right? So this is the midpoint. So I have marked an offset of x by 2 on this side. I have marked an offset of x by 2 on this side. So I know the dimension x, so I converted onto the isometric length. So whatever dimension isometric x will be available, x by 2 will be plotted on this side, x by 2 will be plotted on this side, and two projection lines I have been able to mark over here. Similarly, I know that x dimension will be marked over here, right? Similarly, y dimension has to be marked along this orientation. Now how do I locate y? So please check. In order to locate y along this side, I know this is the point B over here. AB will lie here. AB is going to lie here. Why AB is going to lie here? Because this edge 1, 2, it should be located away from the observer. So this edge 1, 2 has to be located away from the observer and parallel to the vertical plane. So now I know that A and B points, they are lying over here. Now from A and B points, what I have to do over here? I have to measure these distances. Please see, B to this point, that is this point to this point. So this axis distance I have to measure from this side. So this is my axis, this is my axis. So from this axis point, I will be measuring this distance. Please check this distance, and I will be plotting this distance towards my AB line. I will be plotting this distance towards the AB orientation, right? So this will be my line. Similarly, on the other side, I will be measuring this distance, that is O to 4. This distance will be O to 4, and over here I will be marking the distance O to 4. So these two projector lines in this direction, they will be drawn such that this distance, please check, O to this one. So this will be plotted on this side. Similarly, O to 4 distance, it will be plotted on this side. Now please check. This is the location of my Y over here. So this is my distance of X. This is my distance of Y. And this distance of Y has been obtained such that this distance, please check, again I am repeating, this distance, it is equal to axis to this base distance. That is, this will be my now AB line. This will be my AB line, and 1 and 2 will lie here. So this perpendicular distance should be equal to this one. Similarly, the distance of O to 4. So this is O, this will be 4. So this distance will be different over here, right? It is not the midpoint. Okay, so these two distances I have measured and plotted it corresponding to these two lines. So here the offsets, they are different compared to this particular axis line. Now having drawn this rectangle, so please check, this is my edge AB. Now I am going to mark the points over here. This is my A, this is my corner B, this is my corner C, this is my corner D. So this is my rectangle. So deliberately I have used blue colors for this hexagon rectangle over there. So this is a rectangle which is inscribing my pentagon over there. Okay, so this rectangle inscribes my pentagon. So what I have done, I have drawn this rectangle, and having drawn this rectangle, next what I have to do. So please see, next I have to mark the points A1, B2, similarly B3, A5 and C4 over here at the corresponding point. So let me measure the first point. So please check, the first 2 points which I am going to mark over here, they will be A1 and B2. And where they will be marked? They will be marked on this edge AB of the rectangle. So where I have drawn AB, this is my edge AB, right, which is away from the observer, and this edge happens to be parallel to the vertical plane. So from A, I have marked the distance which is equal to A1. Similarly, from B towards A, I have marked this distance which is equal to this distance, and this point name will be point number 2. So let me mark next 2 points which are equal to, please check, B3 and A5. So similar to A1 is equal to 2B, here we have B3 is equal to A5. So that is why both of these points we have marked simultaneously, this point and this point. Let me mark the points. The distance of B to 3 and A to 5 will be equal. So this is A to 5 distance, this is B to 3 distance over here. And we can see in the true construction also, B3 distance happens to be equal to A5 distance. And finally point 4 is left. So we can measure this distance C4 or D4. Otherwise it is the midpoint of CD basically. Now onto this line, please check CD. I have marked this point 4 over here, and we can check this is the midpoint of CD. So point 4 has been located. Now we can see that all the 5 points 1, 2, 3, 4, 5 corresponding to the base of the pentagonal pyramid, they have been identified and located. Now we have to join the edges which are visible to the observer, and we see that edge 3, 4, it is facing the observer, this is visible. Edge 4, 5, it is again visible to the observer and it should be drawn dark. Similarly, the edge 1, 5, it is towards the observer, so this is visible to the observer. And now the cross check, the edge 1, 2 should be drawn away from the observer. So since this edge was drawn away from the observer, this is not visible to the observer. So this should be drawn light. So I am not going to darken this edge 1, 2. Similarly, edge 2 to 3. This is my edge 2, 3. So this is also away from the observer and it has been drawn lighter in nature. So this is lighter construction that is not visible to the observer. This is also lighter construction not visible to the observer. Now, since we had matched this axis of the pentagonal pyramid with the axis of the cylinder, because this pentagonal pyramid was resting centrally on top of the cylinder, so the axis of this pyramid and this cylinder, they have matched. So from this point I am going to draw, this is my O1 point, which is the bottom point of the axis of this pentagonal pyramid. Now from this O1 point, please check, I have drawn the axis height which is equal to 50 millimeter. So we know that the height of this axis of the pentagonal pyramid happens to be 50 millimeter. So we have drawn this distance equal to 50 millimeter. So the apex point, please check, apex point O has been located. The moment we locate this apex point O, I can join different slant edges corresponding to this pentagonal pyramid. So let me join. O3 is visible because it is facing the observer. O4 is visible, it is facing the observer. O5 is also visible. O1 is also visible. So the 4 slant edges of this pyramid, they are visible to the observer, whereas this slant edge O2, this is not visible to the observer. So we have drawn it with a lighter construction over here. So these 3 edges we could have omitted also, right? It's not compulsory that we should join, but we have just shown these 3 edges joined because we want to show the completeness of the construction of this pyramid over there. So this edge and this edge we could have omitted as well, but still just to show the completeness of this particular construction of the pentagonal pyramid, we have joined them with construction line. So these are the thinner lines, not the dark line. Now once we draw the complete pentagonal pyramid on top of the cylinder, now you see what we are observing. We are observing that this portion of the cylinder, this portion of the cylinder has been covered by this pentagonal pyramid. So whatever remaining portion of the cylinder is there which has not been covered by this pyramid, this has to be darkened now. Now I am going to darken the portion of the top face of the cylinder. So this is the top face of the cylinder which has not been covered by this pentagonal pyramid. So this is the construction of a pentagonal pyramid which is resting centrally on top of a cylinder, and we are going to satisfy 2 conditions over here. Condition number 1, that one of the edges, it has been planted or it has been located away from the observer, that is why it is drawn lighter. Second, this edge happens to be parallel to the vertical plane, right? So this is the complete construction of this combination solid that we have completed, right? So I'll just show you another way that how we could have located this. Please check, this is the same construction which we have picked up from the literature, but in this construction all the lighter lines, they have not been shown over here. So this will not provide you the perfect idea, is it a pentagonal pyramid or is it a hexagonal pyramid. So this way you are not able to find it out from here, but by looking at this construction you are able to validate this fact that in the case of a pentagonal pyramid, 5th edge is not visible, whereas even if you draw a hexagonal pyramid on top of this, you will find that only 4 slant edges would have been visible over there. So that is why we insist on drawing these slant edges or the base edges. Even if they are not visible, you draw them lighter over there so that you can have the accurate visualization of the construction that you have made, right? So this is all for today. and we are going to continue with discussion about few more cases of the isometric projections in the coming lectures. So thank you very much. Thanks a lot.